Okay, so we are going to work through how to find the epicenter example. And so here you can see the lag time graph, where if you know the difference between the P wave and the S wave, you can go over to the line using the model and determine the distance from the epicenter. And so let's start with station A. So the first thing we need to do is over here, you can see that we need to determine the arrival of the P wave. And so first thing we need to look at is the bottom of our seismogram and look at the times. So I need to figure out how much each box is worth. And so from 8 p.m. 37 minutes 0 seconds to here is 30 seconds. And I have 1, 2, 3, 4, 5, 6 boxes. So that makes each box worth 5 seconds, and that's going to help us with our estimations. So I'm going to say, looking at this, that about right here is where the first P wave arrives. And so I want to estimate what time that is. So I'm going to go and I'm going to, over here, change the color of my marker, make the line a little thicker, and then I'm going to place a dot about where I think the P waves start, and I'm going to follow that dot down to the timeline. Okay, you could also draw a line if you wanted to. So you could draw a line down to the time bar. Either way works. And so now I need to estimate what is the arrival time. So here I have 0 seconds after 37 minutes, 5, 10, 15, 20, and I know that the next one is 25. So then my answer needs to fall somewhere in between 20 and 25. So I'm going to estimate probably around 22 or 23 seconds is when the P waves arrived. So I'm going to go up and I'm going to change the thickness of my marker. And I'm going to put in a text box. So I'm going to put in 8 p.m., 37 minutes, 23 seconds as the arrival of my P wave. Now what I want to do is I want to determine the arrival of the secondary wave. So I'll change my color, change my thickness again. And so I'm going to go along, and what I'm looking for is the next big change in amplitude of the wave. Remember that amplitude is the distance above or below the median line of the wave. So I'm following along, and this here looks like the next big jump in amplitude. So I'm going to estimate that this is the arrival of the secondary wave. Oh, I don't want a textbook box, sorry. And so I'm going to place my dot, follow my dot down. So now I need to estimate when is the arrival time of my secondary wave. So here's 30 seconds, 35 seconds, 40 seconds. And so I know my answer's got to be in between 40 seconds and 45 seconds. And so it's a little bit this way from my estimate here. So if I made this 23, I think I'm going to make this 42. So 35, 40, 42. So I go up, I'm going to change the thickness, choose text, and the arrival, my estimated arrival time of the secondary wave is going to be 8 o'clock, 37 minutes, 42 seconds. So now what I need to do is determine what is the lag time, meaning how far did the secondary wave lag behind the P wave. And so if I subtract these two, I get 19. So the lag time, or the difference between the arrival of the secondary wave and the primary wave, is 19 seconds. Now I'm going to leave my work here, and I'm going to go and I'm going to look at the lag time graph. And remember, 19 seconds. So I go up here, I'm going to open my graph, and this time I'm going to draw a line. and I'm going to estimate where on the y-axis does 19 fall. This is the S minus P on the y-axis, the lag time. And so you got to figure out the increments of your graph. So on the y-axis, they're each worth 2. And so our value was 19. So I'm going to be right in the middle, right here. I'm going to draw my line over to the graph. Okay. Now I'm going to follow that down to the x-axis. Okay. Now I can determine the distance of the epicenter. So if I look at my x-axis increments, each of these is worth 10. So I know I have 100 kilometers. I know my answer is going to be between 100 and 200. So I got 110, 120, 130, 140. And so I know my answer is going to be in between 140 and 150. So it seems like it's closer to 150. It looks like I might be a little bit, my line might not be quite so straight, so I'm going to put it about right in the middle. And so a good estimate might be 144, 145. Okay, so I'll leave my graph. I'm going to go back here, and let's put in 145 for my distance. So since it says kilometers over here, we don't have to put kilometers over here in our answer because it's assumed. Also the same thing for seconds. So now we're going to draw that circle on the map. That will be our next step. So I'm going to go to my map. And I need to draw a circle that has the radius of 145 kilometers. So remember that 145 kilometers means that the earthquake could happen anywhere that distance away from station A. So we have infinite number of possibilities of where the epicenter could be with our one station. So I'm going to draw a circle. Here's your selection tool that allows you to pick things up and move it. So I want 145. So here's 100. Here's 150. So I want my circle, the radius of my circle, to land about right here. So if you line up these squares with the 0 here, and then try to put the center of your circle where the 0 is, and then, hey, I did pretty well on my first try. So that's pretty good. And so I don't have to change my circle. So now all I got to do is pick up my circle and then center the A in the center. So this should line up here. Not quite centered. There. So anywhere on this purple line, using the data from station A, is where the epicenter occurred. So we're done with station A.